Bismillahirrahmanirrahim. Assalamu alaikum. This is our question number 24, chapter number 1. According to question number 1, we have partial derivative of u with respect to xx plus uyy plus 5u is equal to 0, along with boundary condition u of 0 is u of 0 comma y is equal to 0 and u pi over 6 comma y is equal to 3 into e minus 2y, and limit y approaches to 0 infinity, then the function approaches to 0. Now we are going to solve this problem starting with separation of variables. In separation of variable, we often take u is equal to xy. Now putting this value into our equation number 1, so we get y double prime y x double prime y plus xy double prime plus 5xy is equal to 0 by putting value of u into equation number 1. Now separating x and y by separation of variable, so x double prime of y is equal to minus xy double prime, taking these number to the right hand side. So taking x as a common and divide this x on the other side, we have x double prime divided by minus x. Along with x, we are taking common not only x but also minus x, and y double prime plus 5y divided by y is equal to, say, k. Now this equation is equal to k and this equation is also equal to k. Now what is value of k? K might have three values: 0, pi square, or minus pi, lambda square and minus lambda square. These value depends on the initial and boundary value problem of the condition. On the physical system, these value depends. Now say k is equal to 0, then what happen? We get x is equal to this much and y is equal to this much, but these value does not support our initial boundary condition, therefore we cannot take k is equal to 0. Now let us try. K is equal to lambda square. Now putting this value lambda square, after solving we get the answer of x and answer of y, and we try whether these values satisfy our boundary condition or not. According to our boundary condition, our boundary condition have e in the power of y. Therefore, when we take this lambda square, so we get y is equal to e into power of y. Therefore, k is equal to 0 does not support our physics of the problem. K is equal to minus lambda square does not support the physics of our problem, but k is equal to lambda square support our problem. Therefore, we are taking k is equal to lambda square. Now solving k is equal to lambda square. Solving k is equal to lambda square. So solving this number, we know that this is second order ordinary differential equation and d square is equal to pi square. Taking root on both sides, d is equal to plus minus lambda iota. So according to definition of imaginary complex solution of ordinary differential equation for a complex number, so x is equal to c1 cos lambda x plus c2 sin lambda x, and solving this number we have to answer plus lambda square minus 5 root and minus root x square minus 5. These are two solution, and writing these solution we have c1 is equal to e root lambda square minus 5y plus c4 minus lambda square plus 5 minus 5 root into y. This seems to be satisfy our physics of the problem. Now using initial boundary condition, according to initial boundary condition, this is our value of u because u was x into y. What is value of x? x is equal to this number and y is equal to this number. Putting these two value into u, we get u is equal to x into y in terms of x and y. Now according to condition, u0 is equal u0 y is equal to 0. So what is u0? When x is equal to 0, putting x is equal to 0 in this equation, we get this number. Okay, and if we take derivative of this equation according to our condition, according to our condition, put x is equal to pi over 6. So we are putting here now x is equal to pi over 6 in this value. If we are putting x is equal to pi over 6, then pi over 6 is equal to 3 into e power minus 2y, and putting x is equal to pi in this values, and the C3 and C4 remain same. Now according to our these condition, now we have to decide the value of C1, C2, C3, C4 and lambda. These value, we will decide these value from these two equations. Now from this equation, now we are taking these value from this equation. We have to decide C3 is equal to 0, C4 is equal to 1, and C2 is equal to 3, and C1 is equal to 6. If we decide these values, and we decide lambda square minus 5 is equal to 2, y is equal to 2, because this number, the e power lambda square minus 5 into y, but here e power minus 2, so 2, we are taking lambda square minus 5 is equal to 2, applying square on both sides, so lambda square is equal to 9, so lambda is equal to 3. Therefore we are taking lambda is equal to 3. These 5 values put in this equation will satisfy our PD and also satisfy our IVPs and boundary value problems. Now we have question number 21. According to question number 21, this is our PD and these are our initial condition. We have to solve this PD by using the technique of characteristic equations. So compare this PD with general equation. We have A is equal to 1, B is equal to 0 and C is equal to minus 1 over C square. Our characteristic equation for second order PDE is ABC 1t prime 0 0 1t prime is equal to 0. Now value of A and C and B are given according to from equation number 1. We got the value of ABC, putting value of ABC, solving this determinant and solving this value, taking root this value and solving this differential equation. We have T is equal to plus minus x over C is equal to C. C means we have two values, one with plus and second with minus. So for plus it is equal to C1 and minus is it is equal to C2. Now we are deciding our function zeta and eta. Zeta is equal to, we are taking zeta with respect to addition and taking eta with respect to subtraction. We also know that zeta is equal to, we consider zeta is equal to phi and eta is equal to psi. Now we know that our uxx, utt, these are our values. We got these values by using chain rule. The chain rule is defined in this portion. This portion defined the chain rule from where we got these value of u xx. Similarly, we can find value of utt. Now we have, now putting this value into our PD, we put this values uxx and utt into equation number 1. We get these values. according to this value, and if we multiply c on the right hand side on both side, we get c square uxx is equal to utt. Now c square into uxx, putting the value of uxx, is equal to utt, putting the value of utt. But we know that phi is equal to this number, psi is equal to this number, taking derivative of phi with respect to x, which is equal to taking derivative of phi with respect to x, which must be equal to 1 over c. It will be okay, I write it 1. And if I am, so because I can write this number in this manner, therefore now taking derivative of this number is equal to 1, taking of this number with respect to t is equal to c, and double derivative of both number is equal to 0. Similarly, derivative of psi with respect to x is equal to -1, and derivative of psi with respect to t is equal to c, and both are derivative of 0. Putting all these value into our equation number 2, we get equation number 2 in the simplest form, which was u psi eta is equal to 0, which is required canonical form of partial differential equation. Now solving this canonical form, so del over del zeta into u eta is equal to 0, multiplying del over del zeta on both side. Now taking integral on both side, because eta is equal to constant, therefore this constant is considered at eta. Now del over del eta u is equal to eta, multiplying eta on both side. Now taking integral on both side. After finding this integral, we surely get answer in the form of u eta, in the form of function of eta, and that function can be written as phi of eta. The integration, in this integration our zeta was constant, therefore u is equal to f eta plus g zeta, which is our required solution. Now our solution is of the form, what is value of zeta and eta, putting value of zeta and eta. Now this is our solution, required solution. Now we are going to find solution in such manner, value of f and g, such that it satisfy our PD and our initial and boundary conditions. Therefore PD, therefore we have to find such value of fct minus x and gct minus x. Now uxt is equal to this number. Now taking derivative with respect to t, we get this values, and now using initial condition, putting when t is equal to 0, when t was equal to 0, then ux0 is equal to 0, putting this value into our this equation, in equation of u, when t is equal to 0, t is also equal to 0, t is also equal to 0, we get ux0 is equal to f minus x plus gx. But ux0 was equal to 0 according to our initial condition, therefore this number is equal to 0. This is equation number 2. Now taking derivative of this equation, we take derivative of this equation with respect to t, and also put t is equal to 0 in this equation, and we get equation number that might be equation number 4. Now we get this equation. Now taking integral, this is equation with respect to x, so we consider it now an ordinary differential equation. Now taking integral on both sides, when we take integral on both sides from limit 0 to x, we got value, integral of this number is equal to tan inverse x, and what is integral of f prime, which is equal to minus f, and what is integral of g prime, which is equal to g. Now this is equation 3 and this is equation number 4. Adding equation 1 and 2, we get value of g, and putting g into equation number 2, we get value of f. Putting value of g into f in our original solution, there is a bit problem by putting these value into our equation of u, because in equation of u there is ct minus x and ct plus x. Now here x is, what is f? F is equal to minus x. Now replacing minus x is equal to xt minus x. Therefore we get this value into our f. And similarly replacing ct plus x in place of x, and we get this value. Now this is our required solution which satisfy PD and which is also satisfy boundary and initial conditions. Now our next problem is problem number 26 of chapter number 1. This is in the form of utt is equal to 16uxx with ux0 where x is between 0 and 2, where t is greater than 0. Boundary conditions are given. At boundary, at 0 function is equal to 0 and 2 function is also equal to 0. And ux0 when t was 0, this is equal to 6 sine pi minus 3 sine 4 pi x. And when taking derivative of u, then we get this values as an initial condition utx0 is equal to 0. Also mod of this solution must be less than m. This means it does not goes to infinity when we are taking mod of this number. Now using separation of variable, according to separation of variable, we take u is equal to xt. Putting this value into our equation number 1, we get x t double prime is equal to 16 x double prime t. Now using separation of variable, so x double prime over x is equal to t double prime 16t is equal to k. Now k might be 0 minus pi square or lambda square or lambda. Now I am taking here k is equal to minus lambda square. You guys can check all these values. You first can take k is equal to 0 and check whether it satisfy our initial or boundary condition or not. If not, then you take k is equal to minus lambda square. If it does not satisfy, then you can check k is equal to lambda square. I am checking k is equal to minus lambda square. Putting this value k is equal to lambda square, this equation will be equal to minus lambda square, and this equation also equal be minus lambda square. Now this is second order OD and this is second order OD. So solving these second order ODs, we get x is equal to c1, because this gave us our solution in the form of complex number, and it also gave the solution in the form of complex number. Therefore our solution of x is equal to c1 cos lambda x, c2 sin lambda x, and also t is equal to c3 cos 4 lambda, because it gave us answer of plus minus 4 lambda iota, and it can be written as c3 cos 4 lambda t plus c4 sin lambda t. This to find our required position solution. So putting value of x into t in this equation, putting this value in this equation, we get solution in form of this number. If we multiply these number, we will get solution in this number. If we multiply those number, then we get our solution in form of this number. Now I am trying to solve the values. I am trying to find the value of c1, c2, c3, 4 and lambda. Now using initial condition ux0 is equal to, it is given in our this question, ux0 is equal to this much. Now putting this value, if we put x0, when ux0, it means our here t is equal to 0. So sin t, sin 0 is equal to 0, this number will be vanished, and this is also equal to sin t, and sin t will be vanished, sin 0 will be vanished. This is equal to cos t, and cos 0 is equal to 1, and cos 0 is equal to 1. These number 2 will remains, and these two number will be vanished. This number and this number will be vanished, and this number and this number will be equal to 1. Now I am taking c1 c2 is equal to 6. Why c1 c2 is equal to 6? Because sin sign with this number, this constant is equal to 6. Therefore, I am taking C1, C2 is equal to 6. Also, this is equal to minus 3. So, I am taking what? C2, C4 is equal to minus 2. Solving these two equation, we get C1 is equal to minus 2, C2 is equal to 2, C3 is equal to 6. Now what should be C4? According to our next condition, we will get C4 is equal to 0. This is only option. If C4 is equal to 0, then this, if C is equal to 4, then this equation will be satisfied. Therefore, C4 is equal to 0. Now we will decide what should be the value of pi. Now I am considering this equation. Watch this equation closely. Now I am considering this value. What is this value? This is equal to, this value is equal to 6, and this value is equal to cos lambda x. Here cos lambda x, this is our cos lambda x, but here cos, where is those values? But here I am considering this number sine. Here sine is equal to, here sine was pi x, but here sine was, this was, here sine was lambda x and sine was 4 pi. Therefore lambda is equal to 4 pi. I have got all the values, value of C2, C1, C3, C4 and lambda. Put all these value into our this equation. We will get our required answer. Now this is our last question. In this question we have to convert this PD into canonical form. To converting this PD into canonical form, we will compare this PD with general PD. It will give answer A, B, C. Now using characteristic equation developed previously in chapter number 1. So putting value of A, B, C and solving determinant and solving quadratic equation, because it is now a quadratic equation. Solving quadratic equation, we will get y prime is equal to 3 and y prime is equal to 1 over 3. So for y prime, solving y prime mean dy over dx is equal to 3. This implies that dy is equal to 3 dx. Now taking integral on both side, y is equal to 3x plus constant c1. So y minus 3x is equal to c1. This number will be our zeta, and zeta must be equal to 5. Similarly, we get 1 over 3 and we get our zeta. Zeta is equal to psi. We know that the partial, according to chain rule, our second derivative with respect to x, our second derivative with respect to y, and our derivative with respect to xy. But according to these values, these are value of phi and psi. Taking derivative of these number with respect to x, with respect to double x, with respect to y, with respect to double y, with respect to x, double x, y and double y, we will get surely these values, and put all these value in u double x, in u double x, in u double y, in u xy. Putting these value, we get u double, the answer of double x, similarly answer of double y and answer of u xy. Putting these all values into our equation number 1. This is our equation number 1. Put all these value into our equation number 1. We get if we put these value into equation number 1, the equation number 1 transform into this equation, and after solving this equation we will get u xi eta is equal to 0. This is same as question number 21. You can solve this, but in this question it is only recommended to find the canonical form. This is our required canonical form. Canonical form. That is end of our chapter number 1 and lecture. Thank you guys. Please follow and share this videos, and also comment if you like this video.